Hey everybody, Mr. Chantry here from the Planetarium. Let me get this down a little bit. There we go. That's a little better. Hi, so Mr. Chantry here from Methacton School District's Mallon Planetarium. If you're from Methacton, welcome. Thanks for joining us. If you're from somewhere else and you just came across our video, welcome. My name's Adam Chantry. I'm the director of Methacton School District's Planetarium. I do all kinds of space stuff in our school district planetarium. In normal years, we're in the planetarium. This year, obviously, we're virtual. We're trying out some new streaming things here. So I'm going to be just live streaming the Perseverance rover landing while we're going on here. So right over to this side of me here, you can see that's the NASA live stream on YouTube. And they're going through a lot of things. If you want to pull that up on a browser too, that's just youtube.com/NASA. They have their live stream there of the Perseverance rover. And you can check this out. I figured I'd do this for some of our students and our viewers. Here I'm going to be monitoring just kind of the comments, things like that. I'll be talking about a little bit about what I know about the Perseverance rover and what's going to be going on. You can also go to the Methacton Planetarium website, methacton.org/planetarium. Check out our evening sky excursion space videos about what you can see in the sky. I just did a 15-minute video about the Perseverance rover, kind of everything that you would want to know about it in a quick 15-minute video. Lots of different things that you can see there. If you want to know more about that, I'll post a link to that too. Let me see here. Still working out all of this live streaming stuff. So let's see here. If I bring up my videos, there we go. And I want to copy this. There we go. I'll put a link in the comments to video about Perseverance. So I put links to my 15-minute video all about Perseverance in the chat. So if you want to go and watch that, it's about 15 minutes. So the live stream for NASA started about 2:15. The landing isn't actually set to take place until about 3:55, I think, is the projected landing time as of right now. So we still have a little while if you want to look around at some different things, ask any questions. I'm going to talk a little bit right now about Perseverance and the different things that I know about it. If you have questions that come up, I have all of my planetarium software here too. I can throw those things up live, throw those on the screens, kind of use my streaming stuff here. We'll tune into the NASA broadcast here in a little bit. So Perseverance is the name of the new rover that's going to be landing here in just about an hour or so. This follows up a current rover that's on Mars called Curiosity, or the Mars Science Lab. You may have seen lots of different pictures of that. My background here is actually of a shot from that rover. So this background that I'm seeing here is an actual image from Mars, from the surface of Mars, taken from the Curiosity rover. Rover's about the size of a small SUV, few thousand pounds, which is very difficult to land on another planet. So that's what we're watching here today. This rover left back on July 30th. It launched, and it's been on a almost 7-month journey to get to Mars. In my video, I show a neat animation about where Mars is and how we get to it. Let me see if I can bring up. Let's bring up my. Let's see. Do I have it here? Let's see if it'll let me bring this up. There we go. Here's a little view of the solar system. So the green line is Earth's orbit inside, and then you have Mars's orbit kind of in the orange or red. This is how they're lined up right now. So you can actually see that Earth is further away from Mars right now. It's not very close. If I back up time on this a little bit, so let me go back a few months. So if I scroll back time here, Earth, since it's closer to the sun, it travels faster around the sun, and actually, laps Mars. So Mars and whoops, I jumped gears here. So here's July 30th, when we actually had the rocket leave from Earth, and they use what's called the home and transfer orbit. So basically, Earth is traveling faster than Mars as it goes around the sun. So instead of trying to shoot a straight line right to Mars, what we do is we launch off of Earth, and we use the Earth's momentum, because the Earth's traveling around the sun, to kind of fling the rocket so it comes up behind Mars and eventually catches up with Mars, which takes a little while. So my months are jumping around here. Get us back to where we were. There we go. Ooh. Yeah, my software doesn't like that. I'm trying to run too many of these things. All right. So right around October 13th was when Mars and Earth were actually at their very closest. Look at this. I'm trying to play with my software while I'm doing this. Let's just jump to the 13th. There we go. All right, so on October 13th, you can see Mars and Earth here were at their very closest points to each other. This only happens about every 26 months. So it takes about 2 Earth years before they line back up again. So we only get this opportunity to send something to Mars about once every 2 years. Back in 2018, we did something for, they put a lander that wasn't a rover that drove around, called InSight, on Mars's surface, that is measuring the Earth, well, not earthquakes, Marsquakes, the movements of the surface on Mars. It was supposed to have a probe that was going to dig down about 10 meters to measure the internal temperatures of Mars. Turns out the soil where we put that didn't exactly behave the way we thought it would, that engineers thought it would, to get the probe down in. So it only went in about a foot or so, and they just recently gave up on that. They tried a whole bunch of different things to try to get that to work out, and it didn't, but it's still giving us back lots of really, really good science there on what we can see. So you can see that's where they were back in October. The probe was on its way to catch up with Mars. Now, as we continue around here, bring up, there we go. As we go here through November, December, January, and here we are, February 18th. This is where our probe is approaching the back of Mars, and will be landing today. Now, at this distance between Earth and Mars, it's about 130 million miles. It's really far. The images that I have over here on the screen are not to scale at all. It's blown up so that you can see it a little bit better. So there's 130 million mile separation between us and Mars right now. Light travels at 186,000 miles per second, not per hour, because usually we measure things in like per hour. So light travels at 186,000 miles per second. Even at that speed, that's like 24 times around the Earth's equator in 1 second. That's how fast that is. So light seems instantaneous to us. When we turn on a light, it hits our eyes right away. We don't think about that light having to travel and take time to hit our eyes. But when you're talking about 130 million miles, Well, it does take light a certain amount of time to travel that. So it takes a little over 11 minutes. So when we're trying to communicate with Mars right now, light takes 11 minutes to get from us to Mars, and then from Mars back. The electronic radio signals that we use to communicate with this rover and the spacecrafts is just a form of light. Radio waves are part of what we call the electromagnetic spectrum. They're another form of light. We can't see it. It's a wave that travels through. So it travels at the speed of light. So even when we try to send signals to the spacecraft, it takes 11 minutes for that signal to get to the spacecraft. What's so important about today? They'll be talking about the 7 minutes of terror here on the NASA live stream. And what that is from the time the craft hits the atmosphere of Mars, it's going to take it about 7 minutes to slow down and safely land. Now, Mars's atmosphere is really thin, which causes some problems because it's not thick enough that we can use it as use parachutes to slow us completely down, like we would with the space capsule coming in. Like we have space capsules returning from the International Space Station. It won't slow us down enough. Even with parachutes, it'll only slow the spacecraft down to a few hundred miles an hour, which is still too fast to land safely. So they have to do all the kind of the crazy stuff to land on Mars. So you have to come in. There's a heat shield that slows it down from... So it's traveling around the sun right now at about 50,000 miles per hour. Relative to Mars, because Mars is also traveling around the sun, it's going about 25,000 miles an hour. So it has to slow down from 25,000 miles an hour to a safe stopping speed. So it's going to hit the atmosphere. The atmosphere and the heat shield is going to slow it down to about 900 miles per hour. It's going to deploy a parachute, a supersonic parachute that's made to open at supersonic speeds, faster than the speed of sound, which on Earth at sea level is like 761 miles an hour, I think. Something like that. So it's made to open under extreme speeds, and that'll slow it down to a couple hundred miles an hour. Then the craft will actually cut away from what they call the back shell, and it'll cut away, and it'll actually have like a rocket backpack, and the rockets are what'll slow it down. Then the rockets can't actually land on the ground because it has to be out of that backpack, and the rockets kicking down can kick up lots of dust and everything. So the last 21 feet, it actually lowers the rover down on 4 cables, what they call the sky crane maneuver. So it's this crazy process. And I mean, just to do that here on Earth is very, very difficult to slow something down that much, to get the parachutes to open right, to get the timing right for this to break away, to know where it is, to have this rocket backpack go, to land safely, to do this sky crane maneuver and have everything on there. All of that process takes about 7 minutes. And like I said, right now Mars is 11 light minutes away from us. So even if something went wrong, even if they saw something come up on their computer screens like, hey, this is coming in at the wrong angle, we need to change something, it's already 11 minutes later on Mars. So the whole process took 7 minutes. So it's already either touchdown on Mars for 4 or 5 minutes, or it's already blown up or, not made a perfect landing on the surface of Mars. So the engineers here call this the 7 minutes of terror, because it's a very, very, very complicated. This is the forefront of human engineering and programming to get all of this to run just perfectly. And it all has to happen perfectly in sequence, and there's nothing the engineers can do. They have their hands off the wheels now, and it's just like, I hope all of our work that we've done over the past 10 years or so pays off, and we have a rover safely on the ground. They did this same procedure with the Curiosity rover, which landed back in 2012 and is still, doing its mission and still sending back great, awesome science. So we know it works, but it's really difficult to do. It's something we've only done once before. So it's really difficult to do. It's basically the same exact procedure that they used, except now we do have a little bit of an updated technology on this. As it's coming down on the parachute, it breaks away its heat shield. The heat shield flies away from it, and it has something called terrain relative navigation, which is something that the advancements in technology and basically artificial intelligence. The rover has on it a bunch of stored images, satellite images that we take from our satellites that are going around Mars, of the landing area that's called Jezero Crater. And as it's coming in on that parachute, as soon as that heat shield goes away, it starts having cameras and radars that shoot down to the ground, takes pictures, and tries to match it up with its pictures that it has of the landing site to pick the best place, the safest place to land, to see if there's boulders in the way, to see if where it is. So in these couple of minutes, this artificial intelligence is comparing this data, comparing the pictures, trying to figure out where it is, trying to figure out where the best place to land is. This gives us an opportunity to land in a little bit more rockier, rougher terrain. Before we would have to land in an area that was completely flat and didn't have anything going on. Basically a big wide open space that isn't very interesting as far as geology goes or anything like that. We want to land closer to things like cliffs and boulder fields, because that's actually where all the interesting geology is that will teach us more about that will teach us more about Mars. So this rover's mission is to actually look for signs of ancient life on Mars. So we know from previous rovers and everything that some point in the past, 3 or 4 billion years ago, Mars did have liquid water on its surface. The place where we're landing, Jezero Crater, we're pretty sure was an ancient lake bed with a river that flowed into the crater and then a river that flowed out. We're landing right near where the river flowed into this crater, and it created a river delta. As rivers move, they pick up mud and sediment and everything in the river, and as they go into a lake or something, they drop all of that sediment out, and it makes these piles, these deltas. The Mississippi River Delta down on the Gulf of Mexico is an example of this. And we know from here on Earth, where we find ancient river deltas, we can drill cores into the rocks that those deltas have now formed, and from those rocks we can find lots of fossils and evidence of ancient life here on Earth. So we want to know if life ever did exist on Mars. Earth is the only planet that we know of that we're 100% sure there's life on. So we think that if there was life on Mars, that's if. We're not saying there is. We're saying if there was, if life did form on Mars sometime in the past, it probably would have been in one of these big crater lakes or something like that. And we know that the way these sediments form in these ancient river deltas, that would be a good place to look for fossil evidence of ancient life on Mars. So that's why we want to land near this river delta, so we can look at the rocks and the geology. We can dig down in, take these cores, look for all kinds of different signs of life, and see if life ever did exist on Mars. This won't prove 100% either way. Like, yes, there's life on Mars. There's not. It's actually really, really difficult to do. Scientists aren't very sure if life could still exist on Mars today. It's a very harsh environment. It has a very, very thin atmosphere, about 100 times thinner than here on Earth. So it's almost 100 times less dense. That's almost the difference between, like, here on Earth, the densities of water and air. So think about, like, taking your hand and swishing it around in water and how dense that is, how much resistance it gives you to moving your hand, and then moving your hand around in the air. Air is about 800 times, or is a little less, isn't quite as dense. So it's almost that kind of comparison. If you went through our air here and then moved your hand around on Mars, the air molecules you would feel hitting your hand, if that makes sense. Kind of that comparison of a density of water here on Earth to air is what our air would be to Mars's air, because it's so thin. Um, so with that thin atmosphere, a lot of the sun's radiation gets through. So it's a very radiation heavy environment, which is not conducive for life. When you have lots of radiation, life has a more difficult time surviving. Not saying that it couldn't survive at all, or that there could be, microbial life down below the surface where the rocks and things block it from. But on the surface, probably not. That thin atmosphere, life as we know it, also makes it very difficult for life to survive. So, we don't really think that there could be too much life left, especially on the surface of Mars. Not saying that there's not. I cannot prove either way that there is or there isn't. But things don't look good. So the point of this mission is to look back to see if ancient life ever did exist. Because we think in the past, Mars had conditions that were a lot more like we have here on Earth. And we know everywhere we look here on Earth, we can find life, even in the most extreme conditions and things like that. We can find some form of life, even if it's just little microbes or bacteria. We can see that just about anywhere. So that's the point of this mission, what it's going to be looking for and what it's going to be doing. It also has 2 technology demonstrations on it. So the 2 technology demonstrations that it has, one is a helicopter. So a little drone helicopter. It's about 4 pounds. It has really long blades on it, about 4 foot across. And this will be the first attempt at powered flight on another planet. So it's basically like a little drone. This little drone has a lot of challenges, though. So this is just a technology demonstration, is just what it sounds like. It's basically an experiment that they're running to see if the technology will actually work. Our engineers have figured out, we're like, oh, we're pretty sure this will work. We've tested it under very similar conditions here on Earth. We think it's going to work like this, but we want to test it out. So they take something small and they build it, and they test it out first instead of building like a whole mission around something that they're not 100% sure will work. The reason flying a helicopter, especially on Mars, is so hard is, again, because of that super thin atmosphere. If you think about it, here on Earth, a helicopter works. Its blades spin around and they're angled, and they cut through the air, and they actually push down on the air. They create thrust and go up. But like we said, Mars's atmosphere is 100 times thinner. So there's 100 times less molecules for those rotor blades to push on to lift that helicopter up. So it's not quite as easy as flying here on Earth is, which is actually an engineering challenge just to fly here on Earth. So to fly on another planet, very difficult. Also, the helicopter needs to have artificial intelligence to be able to control itself, again, because of that light lag time between Mars and Earth. So somebody on Earth does send the commands to the helicopter to get it to fly, but once it sends those commands, it takes 11 minutes for those commands to get to the little helicopter. The little helicopter starts to do what it's doing, and it sends back a message saying, okay, I'm doing that, I'm starting to fly, but that message takes 11 minutes to get back to us. So it's 22 minutes since you sent it right now, and we're actually still pretty close. It can be as much as 40-minute lag time between the two. So imagine trying to, control a remote control airplane, but, every time you move the little joystick, it takes 11 minutes before the plane actually does whatever you did, and another 11 minutes before you can see whether it's doing that. It's really, really difficult to do, so it needs this artificial intelligence that can kind of fly it by itself. So this is a little 4-pound helicopter. It's just a little, I think it's about like 10 centimeters by 12 centimeter cube. somewhere around there. It weighs about 4 pounds. It has 2 sets of rotors on it that spin in different directions, which is a little bit different. So typically when you see helicopters here, they have the one rotor that spins around, but helicopters also have that other little rotor back on its tail, and that's because as the rotor of the helicopter is spinning, if you just had that one rotor, eventually the helicopter would start spinning around with that rotor, and flying something that's spinning around would be very difficult. So that's why helicopters kind of have that boom out the back with another little blade on it that keeps the helicopter from twisting around. Engineers didn't want to have to build something like that where you had one rotor, then another little rotor out on the back, and you had to time them out. They found that was too hard, so they found that if you have 2 rotors on top of each other, each spinning in opposite directions, they cancel out that twist that you would have there. So that's how they kind of came around that. So that's going to be one of the first technology demonstrations. So the rover will land. You can see on the NASA live feed here, they're showing you how big that rover is. You can see that person standing next to it there with the one camera stuck all the way up. It's even taller than him. So the rover will land. It'll send back some images just to show that it's safe on the ground, what's going on, get some good press, things like that. Then they actually have to update all of the software. So you can imagine, the software, the computer programs that it takes for all of those landing procedures to happen precisely take up a lot of space. So what they actually do is they offload some of the software and they upload new software that's going to have it run, and that takes a little while because it's not hardwired to anywhere here on Earth. So that takes a little while for all of that software to go through when they run it, and they'll test it out. And then pretty soon after that, they're going to drop this little helicopter out from underneath of the rover. The rover's going to drive away about 100 meters, and then they'll be doing this technology demonstration with this helicopter. Another technology demonstration that this has on it is a little box called Moxie. And it's just a little 1 foot by 1 foot box, but it's an experiment, and the experiment is trying to show that you can take the Martian atmosphere. So the Martian atmosphere, like I said, really thin, 100 times thinner than Earth's atmosphere. And it's also mostly made up of just carbon dioxide. There's I think there is some trace oxygen in it, but a very, 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 very small amount. Not like the 20% oxygen that we typically have here on Earth. Very small amount. So what this Moxie experiment is going to do, it's going to pull in that carbon dioxide from the Martian atmosphere. And carbon dioxide is just a carbon atom with 2 oxygen atoms, carbon dioxide, or CO2. And if it can break that carbon off and just produce the oxygen, which is basically what plants do here on Earth. They take in carbon dioxide, they put it through a process, and they basically breathe out oxygen. That's why our atmosphere has so much oxygen, is because a lot of the plants and different algae and things here on Earth, oxygen breaks down very quickly. It's very reactive with things in the atmosphere. So if we didn't constantly have the plants on Earth putting out that oxygen, it would go away pretty quickly. So what this experiment is going to try to do is see if we can, we know we can chemically do it. It's easy. We know how the chemistry works to take carbon dioxide and put out oxygen, but it's going to test, how much it can actually do, how much oxygen it can actually pull out of the Martian atmosphere. That'll be important because if we want people to go to Mars, they're going to have to breathe. And like I said, Mars and Earth, the way that they orbit around each other, or they orbit around the sun, if I bring this image back up again, it takes about two years for them to line up. So the only time we can send rocket ships, whether they're with rovers or with people on them, is every 2 years. So if you're going to send people to Mars, they're going to be gone for at least 2 years in space. And when you get to space, there isn't food, there isn't water, there isn't air. So think about how much water you drink in 2 years, how much food you eat in 2 years, and how much air you breathe in 2 years. That's a lot. So to take 2 years worth of supplies for 2, 3, 4, 5 people, that's a lot. And it costs a lot to put all of that stuff into space. So this would be a benefit, if when astronauts get to Mars, if they can make their own oxygen, or if we can send a mission before them to land on the surface to start making oxygen and kind of tank it for us, so when we get there, we don't have to carry as much with us. Also, oxygen can be used as an oxidizer in rocket fuel. So it's a main part of, you basically have liquid hydrogen, liquid oxygen, you mix them together, and you have rocket fuel. That's how they make some rocket fuels. So you could actually produce rocket fuel on Mars too from the atmosphere. So this is just a very little box. It's just going to be producing a little bit of it, but it's to give scientists that actual data from on Mars, like, okay, how much oxygen can we actually pull out of, over a certain amount of time, and can we then scale that up to actually produce more oxygen that people would be able to breathe and things like that. So those are the two technology demonstrations that you can learn about as this process goes through. Again, all of this is going to take a long time. Today is just the landing of this rover here on this. I have to check on one thing. I'm going to turn off my video here, and I'm just going to bring back up this live stream. I'll make it a little bit bigger. I'll put the sound on it. I'll jump back in here in a couple minutes. If you have any questions about Mars, landing on Mars, things like that, if you're watching us on Facebook, go ahead, type it in the comments. I'll see it here. Same thing on YouTube. I see some people on YouTube. Feel free to type in a question there. I'll do my best to answer it. Like I said, I can pull up different images and pull up some of the Planetarium software there. I'm still figuring out a little bit of this. So stay tuned. Again, the landing won't happen until about 3:55, so we got about 40 minutes. So plenty of time to answer questions. I'll come back on and talk and go over a little bit more of that in a minute or so. But I'll pull up the sound for the NASA live stream here, and you can listen to that.
To change how we think about Mars and how we think about life in the solar system.
That was a great question, Lori. Reach for the stars, future little scientists and engineers. Thank you so much for joining us here today, Lori.
It's my pleasure. Thanks.
Back to you, Raquel, for another mission update.
Thanks, Marina. The cruise team for Perseverance controls the rover on its way to Mars. And moments ago, they handed it over to the landing team. And it looks like team leaders in Mission Control are about to talk to both teams. So let's listen in.
The CBM change, as I mentioned previously, is to the EDL reserve to a non-coherent row.
Activity.
Copy flight.
EDL phase, go ahead.
I'd like to see pep talk, I guess, to the team. Right. I'm terrible at pep talks. I think my reputation precedes me there. And look, I know this hasn't been easy, right? I'm not even sure we've even been all in the same room at the same time. I mean, I'm staring at folks across the internet as well. Even now, right? Yeah. Voice check. Okay. I do want to just extend my heartfelt appreciation from the EDL team to the launch cruise team. You've done everything we've asked for, right? I mean, you've battled anomalies, you've dealt with Cepheids, you've done everything. You delivered a healthy spacecraft to the place that we want to go. And she's right on target, right? You did the last maneuver literally 2 months ago, right? This is pretty incredible, in my opinion. And she's armed with the right information to help us land. Doing the parameter update last night, we're ready to roll. You've done everything right. And you've put up with us, too, right? You've put up with our eccentricities and the things we like to do in EDL land. So I very much appreciate that. So you all should sleep in on Friday since, you guys have earned it. thanks for literally and figuratively putting us in the right position to succeed. And let's land on Mars together.
Copy EDL phase. And as flight director, I also would like to thank the whole team, cruise ops, EDL team, and the surface ops as well. It's been an amazing journey. I think we all know that. And it's been my honor and pleasure to work with you all side by side. And your tireless efforts and endurance in the face of our challenges has been truly, truly inspiring. So kudos to you. Mission, would you like to say something?
Yeah, just echoing the same words that Al and Magdi have mentioned. You guys have overcome great obstacles in the last 6.5 months, and it started with an earthquake in this room on launch day at L-20 minutes. So I can't be more proud than all of the achievements that you guys have pulled off in the last 6.5 months. Whatever happens in the next hour and a half, you can be proud of the achievements that you've accomplished so far. I look forward to seeing you on the other side, and I only wish that the rest of our team could be sharing this moment with us. This is a very unusual event. This room is only half as full as it would be if we weren't in this pandemic. So missing everybody on the team who's not with us here today. And go EDL.
Welcome to the EDL family.
And with that, Godspeed Perseverance. All right, activity. Go ahead and continue the report.
Sure thing, Flight. We've since completed the EDL start anchor. As I was mentioning, we changed our CBM row to EDL reserve two-way non-coherent. That row reinforces our CBM windows disabled, keeps our packetization on, it turns off our ranging and switches to the auxiliary oscillator. We have also started our real-time data products and reinforced Medley on. At this time,
Now, we just heard Perseverance team leaders thank the cruise team for their work in guiding the rover to Mars. Now, did you know the rover name and Mars helicopter name came from students? Well, a couple weeks ago, Marina was able to catch up with them.
Thanks, Raquel. Earlier this year, NASA and our partners held a nationwide essay contest to name our Mars rover. Alex Mather, a 7th grader from Springfield, Virginia, submitted the winning essay that was selected by NASA from a field of more than 28,000 entries from K through 12 students in every state in the U.S. Vanessa Rupani's essay for Ingenuity was so compelling, NASA thought it would be a perfect name for the history-making helicopter, a technology demonstration carried aboard the Perseverance rover. Alex and Vanessa join us now. Welcome, you guys.
Hello, space nerds.
Hi.
Now, you got to go to Florida and watch the launch live back in July. Alex, what were you feeling as you saw that rocket launch into the sky?
I read a lot of books written by astronauts, and every single one of them always talks about the raw power behind a space launch. And I definitely feel like watching the launch invoked that sense of inspiration mixed with anticipation, along with that rumble in my chest.
That's very inspirational, and I'm sure that you have had many conversations with your classmates since this all began. Now, what kind of questions have they asked you?
I got some people asking me about what this helicopter is, what this rover is, what are they actually going to do. So I love that this whole experience sparked a greater interest in the mission in my community.
Why do you think it's so important for kids to be inspired by space exploration?
Because space is the future, and kids are the future. Learning about space and watching the story of humanity spread to the stars happen is watching the future happen and seeing history unfold.
The best way to keep our home safe and protect our planet is to learn from the worlds around it. So I think it's really important for the next generation of scientists to be engaged in that type of exploration to make our home the best place it can be.
Now, speaking of the future, what has your life been like since naming the rover and helicopter? Has it sparked any future aspirations for the two of you?
Oh man, I am currently applying to a science and technology school for high school. hoping for a NASA internship sometime along the way, with my ultimate goal being to join the incredible team of scientists and engineers who are about to make this happen.
This whole experience has definitely shown me that I want to go into the space industry. I came home from Florida, did all my college applications, and checked aerospace engineering on all the boxes. I mean, the whole time we were there, I was thinking, why would anyone want to do anything else?
So true. And the best of luck to both of you. Thank you so much for joining us here today, Alex and Vanessa.
Thank you for having us.
Thank you so much. I had a great time.
Now, your essays, as well as the top 155 finalist essays, are riding on the Perseverance rover, along with nearly 11 million of the names from all over the world that were submitted before launch. And if you miss the chance to get your name on Perseverance, then you will get another chance to reserve a spot on the next mission to Mars. So make sure that you sign up now at mars.nasa.gov for your boarding pass.
So we just saw there on the NASA live stream, they were interviewing two of the students who wrote essays that actually named this rover Perseverance. For a while it was just called the Mars 2020 rover. And NASA usually does different types of, all kinds of student contests, essay contests, naming contests, things like that. So anything nasa.gov, there's lots of things to do on their website. Not only for older people, but for students who want to get interested in space and doing things. They have all kinds of essay contests. I try to post them on the Planetarium website from time to time when I get through them. There's actually so many I can't keep up with them all the time. I usually find the interesting ones and I try to post them there. Or if you follow NASA on social media, they also post a lot of that there. And actually, just out of the blue this morning, I had a student named Connor send me a video that he made. He was so excited about the Perseverance rover landing today. He actually did an animation using Google Slides, which I thought was really innovative. He did basically a stop motion with Google Slides and made me a little video about landing rovers on Mars, and I thought it was really great. And I asked him if I could use it here. So Connor, if you're watching, I'm gonna show you your little animation that you did really quickly. He shared it with me, and it just as a reminder. I see lots of students and things in the live stream chats and things like that. Be sure if you're going to be online, be a good digital citizen. There's no problem with that. Make sure you never want to share too much information online. Things like sharing your last name or where you go to school. That's information that other people can see. You don't always want to share things like that. So if I've removed something from the chat, it's not because somebody's being disrespectful or anything like that. Everybody's being good in the chat. Just you always want to remember, the student said, "Oh yeah, you can share it," and I said, I wouldn't share their last name or anything. So this was Connor's video that he made. So let me bring it up here. Let me see if it'll still. Okay, here we go. Yeah, I thought this was really cool. He got different images for the background and for the rocket and for our red planet Mars there. It's a little rover moving around. That's actually the Pathfinder rover, which was an older rover that has since stopped working on the surface there. And then animated some Mars facts here. Average. He even got so we use average distance from the sun because actually as these planets go around the sun, although their orbits or the path that they travel around the sun looks like it's a circle, they're actually slightly oval. So that oval, sometimes they're a little bit closer and a little bit further away from the sun. But thank you for that, Connor. That was a really good video. I thought that was a really neat, innovative idea too, to use that Google Slides as kind of a stop motion feature, so that you could kind of animate that together. I was really impressed by that. Thank you for thinking to share it with me. I really did enjoy that there. Let me just see here. So as we're counting down here, we're getting a little bit closer. We still have about 25, 30 minutes before the rover's actually going to touch down. Now, we probably won't be able to see it tonight. Let me see if I can bring up. I didn't put it here. Let me add. Let's see. Let me bring up an image here. Actually, I can do it this way. We'll do it like this. I'm going to bring up our Planetarium software, and I'm going to play with it a little bit here. Now, here, the Planetarium software that I use here, this is what you would normally see in the Planetarium over here. That's why it's round. Remember, in our Planetarium, it's like a big dome or a bowl over our head, and that's how it projects it over our head. Here on the screen, it looks like a circle. I don't have software to flatten that out and make it look flat screen. So that's what the sky would look like right over our heads right now if it wasn't still snowing and sleeting outside like it is right now. And I'm going to take us to tonight here a little bit. Let's see. And if we were to go outside tonight, if it wasn't completely cloudy out, I don't think as of right now that it's supposed to get any clearer tonight. I think it's supposed to basically stay cloudy and everything like that. Let's see, when's the next clear evening supposed to be? Yeah, we got snow all tonight. No, tomorrow's just supposed to have a few clouds, so tomorrow night will be fine. Mars is in our sky right now. You can see it really easily. No telescope, no binoculars, anything like that. Let me bring it over here. Let's see if I can zoom it in a little bit. No, that's why. Let me get my tool slipped over here. And if we zoom in a little bit here. So tonight, if we were able to go out and look up in the sky, if it wasn't going to be cloudy, Mars would be super easy to find. It is just above the moon. So if you see the crescent moon there, just above it, that little red spot, that would be Mars. Now, if you go out looking for it tomorrow night it is supposed to be clear. It won't be that close to the moon. So remember, as the moon orbits around the Earth. So it takes 29.5 days for the moon to go around the Earth. So it appears to move in our sky from night to night. It doesn't stay in the same spot. So if I jump us over to tomorrow night, like this, you can see the moon appeared to move to the left a little bit. Mars is still right there. Let's show you Mars there again. Mars is right over here. So if tomorrow night you go out, you can see, you'll find it's the first quarter moon. So it looks like a capital letter D there. If you go off the rounded part and go just to the right of the moon, that reddish colored star, that's the planet Mars. It's about 130 million miles away from us right now. The sunlight reflects off of it and reflects back to us. That's how we're able to see Mars, the reddish colored planet. It appears red in the sky because, as you can see from this image from the Curiosity rover that I have as my background, the surface, the actual rocks on Mars are a reddish color. That's because they have a lot of iron content in the rocks. And just like if you have something made out of iron here on Earth and you leave it outside for a while, it gets rusty. It oxidizes. It gets that rusty orange color. So that's why the rocks on Mars look this orange reddish color, because of the iron content that's in them that has oxidized or rusted. So the whole planet is reddish in color when the sunlight reflects off of it and comes back to us. It looks that reddish color to us. So that's how you can find Mars really easily in the nighttime sky. Again, tonight, probably not going to see it. It's supposed to be cloudy. We're only supposed to have a couple of clouds. So go out tomorrow night, anytime after sunset, I'd say from like 6:30. Let's see if I back up time a little bit here. Yeah, really anytime from like 6 o'clock on, you should be able to find Mars. 6:30. Look for that first quarter moon, or that D-shaped moon. Sometimes people call it a half moon. It's actually quarter moon because you're seeing half of the moon. But it's called the first quarter moon, which looks like the capital letter D. Go straight off of the round part of it, pointing out, and that reddish dot there, that will be the planet Mars. And let me see, can we travel to Mars here? Let me see if it'll let me go to Mars. Let's see, can we leave Earth and travel off to Mars? Yeah, let's see. Hi, yeah, here we are at Mars. It did let me travel there. Let me set it up here so we can hover as Mars rotates. We'll speed up time a little bit here. So we can watch Mars go around. Here's one of the moons of Mars. I don't know if that's Phobos or Deimos. Mars has two little tiny moons. They're only a couple miles across, and they travel around Mars much quicker. But it has two of the moons there. We can see it. Mars has these light areas and dark areas. That's just the different terrain that we're seeing, higher regions, lower regions. But it's all got this kind of reddish color to it. The kind of lighter areas, those are the flatter areas. Those are plains. In Latin, they call them planitia. So those kind of flat areas are the planetias. The raised areas are the higher areas that you can see on Mars. Perseverance is landing in a region called the Sidious Planitia, which is one of these big flat areas, but it's right on the edge of it, in a big crater called Jezero Crater. This is a huge crater a few miles across that we think used to be an ancient lake. So it was a crater that was formed when something slammed into Mars, filled in with water from what we can tell. Right here on Mars is actually an interesting feature, kind of looking straight at it. Right kind of in the center of Mars, if you see that little circular area. Let me see if I can zoom in on it a little bit more. Yep, right there. That is the largest volcano in the solar system. It's called Olympus Mons. I think it's 4 or 5 times taller than Everest. So it's really big. It's an ancient, from what we can tell, pretty sure it's an extinct volcano. We can't be 100% sure yet, because sometimes volcanoes can be dormant for millions of years and things like that. We're pretty sure that it's an extinct volcano and it hasn't been active in quite some time. I was just reading an article a few weeks ago of some geology that they were doing on, some planetary scientists were doing on Mars, and they think maybe it isn't as volcanically inactive as we thought it was. So we thought the volcanoes on Mars have all been gone for billions of years, and they think maybe they were active as few as a few tens or hundreds of millions of years ago. Again, in our time, yeah, they're extinct. They don't happen anymore. In geologic time, like 100 million years ago is like, oh, that wasn't that long ago. That was like last week, when you're talking about geologic time. So, but that's the largest volcano in the solar system, Olympus Mons. It's very huge. It's from years of the lava building up on there. The mountains can get higher on Mars because there's less gravity, so the rock can kind of stack up higher before it topples over, before gravity kind of takes over there. So that's why it can kind of build up a little bit higher there on Mars. And then if we keep going, we should see one of the largest valleys here on Mars. If we let this keep spinning around here for a second. Let's see, where is it? Coming up around here should be the Valles Marineris. Let's see. It might be. Might have to wait till it comes into the sunlight here. Should be somewhere over here, but it's a valley about 3 times deeper than the Grand Canyon. So if you've ever gone and like looked out over the Grand Canyon, imagine 3 times deeper than that. And if it was here on Earth, like the size of it, it would stretch about the size of the United States from about New Jersey to California. So 3 times deeper than the 3 times deeper than the Grand Canyon, and spanning almost the entire United States, is that Valles Marineris. Let me see if I can. It's a very easy feature to see once you see it here on Mars. Speed this up a little bit. Might be on the wrong angle here too. I gotta wait till the right season comes along. There we go. Right down in the bottom there. That's our Valles Marineris there. Very deep valley. Let me just check in here. Oh, somebody just asked, why does Mars look like it's so close to Earth? When I brought up that picture a little bit easier, we talk about this a little bit more when our 6th graders come into the planetarium, and when other people come into the planetarium. What we see, especially in the planetarium and in animations in space and everything, isn't always to scale. If we were actually this far from the sun so that we could see all of Earth's path around the sun and all of Mars's path around the sun, you wouldn't be able to see these 2 planets. They'd be so tiny, they'd be little specks, because space is just unfathomably big. So when we're doing visuals like this, we kind of fudge it a little bit. You know, I've made the Earth and Mars a little bit bigger here so you can actually see it. But if I was close enough to Earth to actually make it look that big, you wouldn't be able to see the sun or Mars. So we kind of fudge the images a little bit just to make it so we can actually see things and understand how they work. This is what we call a scientific model. It's just a model to kind of show generally how something is. This isn't a perfect scale model where everything's the right size. So you're right, Mars does look like it's a lot closer to us here in this picture. Like, oh, you can just go from there to there, where it's actually much more difficult. I do this with the 6th graders. I make an actual scale model of the solar system at Arcola, and we put it outside and we walk through some of it. We can't actually even walk through all of it because it's too big to actually get through, and you really start to get how far away these places are. The farthest place we've ever sent humans is the moon, and that's 250,000 miles away. When we lay out like this scale model, it's like 1.5 inches from the Earth, and Mars is just 130 million miles away from us. So yeah, it's a big difference. So this is just kind of a little thing. Now, in our nighttime sky, if I went to the sky tonight, if I just go here and take us to about 6:30, it doesn't look. It just looks like a little dot in the sky. It looks like a reddish colored star. So it doesn't look that close to us. I can make it look so close because I can, use the planetarium here to fly through. This is the same software that we use in the planetarium, and we can fly through that. So let me just check in on the live stream here. Let's see how that's going. Oh, here, I think they're talking about the landing here. I'm going to jump back in and put the audio back on for this.
By the cruise stage as it passed through our beam to the Earth.
Telecom indicated actually that we could see a signal that the cruise stage went between the Perseverance entry capsule and Earth. So we saw a little blip, the data stream indicating the cruise stage separation. We have confirmation that the vehicle has started warming up those entry thrusters. Warm-up pulses have begun.
Okay, so here we go. This is where it's going to start going. So it just got rid of its cruise stage. So that was kind of like...
At this point, the spacecraft is trying to stop its spin from the cruise 2 revolutions per minute down to 0, and then will turn to its desired orientation from entry. It will separate the 2 balance masks that have kept it balanced during all of cruise. This will allow the entry capsule to have lift when it enters the atmosphere. We have confirmation that the spacecraft has turned to the desired entry altitude. We're about 7.5 minutes from entry interface.
All right, so what they're talking about right now, so you saw that capsule that kind of...
the vehicle is pointed in the right direction. Thrusters are warmed up and doing their job.
That's what it's traveled in, and it actually kind of had a ring around the back of it with solar panels and a couple of other little thrusters that it used to communicate and do a bunch of things in the 7 months since it's been traveling to Mars. So they saw it that that backpack just flew away from it and kind of interrupted their signal for a second. And they said they're starting to see warming in it. So you see on the clock there in the NASA, I'm actually going to make this a little bit, move my screen around here a little bit. Make this a little bit bigger. So you can start to see it a little bit better. So down in the bottom right, you see that clock, it says atmospheric entry. So it's traveling at, I think I saw on the last update of telemetry, at about 10,000 miles an hour relative to Mars' surface. So in about 6 minutes is when that 7 minutes of terror is going to start happening, where it's going to start hitting that atmosphere and slowing down and starts going through a process that they call EDL, entry, descent, and landing. It's that 7 minutes of, it's got to slow down in the atmosphere, supersonic parachute's got to go, it's got to drop away. So this is when it's going to start getting exciting. Any questions that come up? I'm just going to kind of let the NASA live stream keep going here, and I'll just kind of comment in on it as I hear things that come up. If you have questions, again, type them in the chat, and I'll see if I can answer them. If I know them when they start getting into some of like the really technical stuff, I might not be able to. I might not be able to get all of it there, but I'll do my best to try to answer that. So I'll put the sound back on here for this.
And streaming it to Earth in near real time. There are a few expected short outages, such as when we have a plasma blackout or when we enter the peak heating phase. Aside from these outages caused by the plasma blackout, antenna switching, or high dynamic events, spacecraft events, we should have telemetry until about 90 seconds after landing. A plasma blackout is when the signal from Perseverance isn't strong enough to make it through the superheated, super fast air flowing around the spacecraft all the way down to Earth. Once the temperature drops below that peak heating, we do reacquire the signal from Perseverance. We are currently about 4.5 minutes from entry interface. Perseverance continues to report heartbeat tones, indicating everything is nominal.
Okay, what we're looking for now is Mars Reconnaissance Orbiter should be in view soon of our vehicle and be able to listen to ones and zeros coming from a separate radio that's really designed to talk between spacecraft.
MRO reports the electro radio is powered on, ready to receive signals from the lander.
Okay, MRO is ready and able and waiting for to hear from our rover.
Mars Reconnaissance Orbiter has reported that it's ready to receive the signals from Perseverance. It should be in a few minutes here. We're just
Flight Local 1
from entry interface.
So there's a bunch of different ways that they're getting information back from this rover to kind of check on it. So it sends what they call a heartbeat, just kind of like a tone directly back to Earth. It just takes that 11 light minutes to travel there. But then we have 2 satellites going around Mars, one called the Mars Reconnaissance Orbiter, and it's going to start communicating with that and getting information from that. That can do information a little bit quicker. It can store some of that information and start sending it back to Earth a little bit easier, where the lander needs a lot of its computer processing to like really focus on landing. It's kind of like driving and talking on a cell phone. The computer's on the lander. Like, you don't want it trying to do too many things. You just want it to be focused on just drive, just land. So this Mars Reconnaissance Orbiter is a little bit closer. It's easier for it to communicate with it and can kind of bounce the signal off of that, so it can focus mostly on landing. It can focus its computer processing on that.
That we've defined to be above the atmosphere. But from that point on, there's definitely atmosphere, and above it there isn't.
We are 2 minutes from entry interface. Perseverance is to transmit heartbeat tones indicating everything is nominal.
You'll hear they keep using the word nominal. So nominal means normal. It's what they expect to see. So nominal is always good. When they say things are nominal, it's right where they expect it to be. All good to go.
We're just under 2 minutes from entry interface. As it gets closer to Mars, Perseverance is actually being pulled in by gravity and accelerating. By the time Perseverance reaches entry interface point, she should be going just under 5.4 kilometers per second. We're at about 90 seconds from entry interface and standing by for Mars Reconnaissance Orbiter to pick up the telemetry.
Telemetry is just a fancy word for all of that computer information coming down. So it tells it its speed, its distance. So it's sending out all of this information from the hundreds or thousands of sensors that it has on it, talking about its speed and the conditions that it's under and what's going on with it right then. So that's what telemetry is when they keep saying it's looking for telemetry.
We are 1 minute.
It's looking for that information.
Interface.
All right, so we got 1 minute until that start of the 7 minutes terror of the entry interface. When it starts hitting that atmosphere, it's going to start warming up. It's going to start slowing down from that about 12,000 miles or 25,000 miles an hour.
MROs are in receive mode.
Or 12,000 miles an hour to.
We have confirmation that the Mars Reconnaissance Orbiter is now relaying data from Perseverance. We're about 30 seconds from entry interface. Perseverance is going about 5.2 kilometers per second and is about 190 kilometers altitude above the surface of Mars.
Confirm your jet data flow.
All right, so here's the data flow coming from it. You can see its speed. They're measuring it in meters per second.
Seconds from entry interface. 5.3 kilometers per second and an altitude of about 150 kilometers from the surface of Mars. We have confirmation of entry interface. Perseverance is currently going 5.3 kilometers per second at an altitude of about 120 kilometers from the surface of Mars.
All right, so this is where everybody's biting their nails. There's no turning back now.
Until it begins feeling the atmosphere of Mars slow it down. Once there is enough atmosphere, it will start controlling its path to the landing target.
So right now it's still in the very, very thin atmosphere. It can't really control and move
Navigation
around.
is also confirming that we can see a little bit of that slowdown of the atmosphere on the Perseverance entry capsule.
All right, so as it's hitting that
Our current
air,
velocity is about 5.36 kilometers per second and an altitude of about 67 kilometers from the surface.
it's starting to slow down a little bit, and they can see that.
Blackout at this point.
All right, so we've hit the atmosphere.
The vehicle should be doing its turns right now.
Amarillo has lost lock.
Perseverance. We have indications that Perseverance is now performing bank reversals in the atmosphere. These are the steps in order to control its distance to the landing target. Perseverance has just passed through the point of maximum deceleration and has indicated that it felt approximately 10 Earth Gs of deceleration.
Amarillo has lock again.
All right, so that's a lot. That's like if you've ever been in a car that slows down really quickly
We saw
and
a small outage
you get kind of pulled.
of the UHF telemetry from Mars Reconnaissance Orbiter during that peak heating phase, likely caused by the plasma blackout. Perseverance is still continuing to perform bank reversals in the atmosphere to control its distance to the landing target.
So now it's actually like flying in the atmosphere. It's using the atmosphere to kind of move around and get it targeted right on where it wants to land. Just landing on the planet is hard. Landing in a very specific area is
Perseverance
really,
is
really
going
hard.
about 1 kilometers per second at an altitude of about 16 kilometers from the surface of Mars.
All right, here we go.
We have
16
entered
kilometers.
heading alignment, which means Perseverance is no longer trying to control the distance to Mars, to the target on Mars, but instead is flying straight to the target.
All right, so the next thing's going to be... Next big thing's going to be the parachute deployment. It's going to... The atmosphere is going to slow it down enough where it can deploy this supersonic parachute. And we'll see. You can kind of see there's on the left-hand side of the screen there, they have a bunch of the steps going down. So we're at step 13 right now.
Velocity is about 550 meters per second at an altitude of about 15 kilometers from the surface.
Amarillo's reporting good telemetry log.
We are coming upon the straighten up. We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Here we go. All right, so it's kind of coming in like this.
Navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Awesome. So the parachute's open, and they know it's open because they can see the spacecraft slowing down. We don't actually... What you're seeing there is a computer simulation of what's going on. You know, they're not getting this information back real time.
Slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Awesome. So the heat shield came off the bottom. It can see Mars. That artificial intelligence starting to figure out where it is, how high it is, where it wants to be, how fast it's going, so it can slow down the right way. So now it's going to drop off of that parachute and try to slow down with rockets. So here we go. Now we're getting into the really hard part. This is really exciting. Almost there.
Perseverance now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers of the surface.
Awesome. So it means that the computer knows where it is. It's controlling it.
Continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
Awesome. Everything seems to be going perfectly right now.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Awesome. It means the software all worked. It figured out where it wants to land. It knows where it's going now.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
TRN Safety Bravo.
All right, now it's
We have
flying
completed
on the
our terrain
rockets.
relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars.
Awesome. When it gets down to that like last 3 or 4 meters, that's when it's gonna, or last 7 meters, it's gonna do that sky crane maneuver and lower it down
We have
onto the
started our
surface.
constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver.
We've lost direct to Earth tones.
So it's holding it.
As expected.
So you want to listen
Sky crane
for,
maneuver has started,
they'll say Tango Delta
about 20
nominal.
meters off the surface.
Yes. Here we go.
We're getting signals from MRO.
Where is it?
UHF is good.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.
Yes. Awesome. So they know it's on the surface, it's not moving anymore. Exactly what they want.
At this point, the descent stage has flown away to a safe distance. Perseverance is continuing to transmit direct through Mars Reconnaissance Orbiter to Earth.
Awesome. And it's still sending information up to the Mars Reconnaissance Orbiter, which means it landed safe. It's still working. It's still sending information. So didn't crash, didn't hit too hard. Everything's good. We just landed another rover on the surface of Mars. So we now have 2 rovers about the size of small SUVs
from the lander.
driving around.
All right, all stations.
We got it.
Touchdown confirmed. We're going to wait for the images.
Wow.
This is so exciting.
All right, so
And
now
the
it's going to
team is
send back some
beside themselves.
images.
It's so surreal.
It's a little bit harder than text messaging a photo over your phone. Takes a little bit more to put all of that information together, send it up to the satellite, send it back to the Earth. But we should get, it won't be an awesome image like the one I have behind us here. Well, it might be. I don't know. But it'll be kind of a quick image just to kind of confirm what's going on here. This is always my favorite part,
Yeah,
like
we
when you see the
just
first
heard the
image.
news that Perseverance is alive on the surface of Mars.
So the rover's there. It's safe. It's sending information back to us. We're waiting for this first image to come back. It won't be a perfect image.
We've just heard the news that Perseverance is alive on the surface of Mars.
Is that the image?
Congratulations to the mission.
Can you share the image?
Looks like we have more news in. It looks like we're getting the first image. Here, take a look at the first image.
And there it is, that little. See if they make it a little bit bigger. It'll be a little black and white. And
We are ready, well, 3. Go for it.
see, I'm watching it on 2 different monitors here. I'm trying to see which one gets it first.
I'll be moving in, showing you the safe zone that we landed in.
There we go. So there's the image from Mars. You can see the shadow of the rover landing down.
Perseverance on the surface of Mars. Now, it comes from the engineering camera known as the hazard camera. This camera is mainly used photos later in the day.
So there'll be much better images coming. This is just like the first quick snapshot that they send out, just to show that it's safe, that the rover's not upside down or anything like that. It's all good. Looking great. They will stitch together a bunch of images from this camera and a couple of others, and there eventually will be a video of the landing. Like, you'll be able to see, like, you're sitting in the rover and you'll see Mars coming up there. There's an awesome YouTube video on that. For the Curiosity rover back in 2012, you can actually watch it land. That'll take a couple of days to get all of that information and those images back. It takes a lot longer to upload and send those back. So the information goes from the rover, it goes up to one of the satellites that we have going around Mars. Then those satellites send it back to what we call the Deep Space Network here on Earth. That's 3 gigantic radio dishes spread out around the Earth. There's one in California, one in Spain, and one in Australia. And they're specifically spread around. Let's see, this is the second image. Alright, so you can see some of the rocks there. Oops.
They're near the ground, so these are pretty close. You can see the wheels there. And they're a little dirty because we've got glass covers over these cameras. But we took these seconds after landing, so there's still dust in the air from our landing event. So this is happening. This happened just seconds ago. Just arrived.
Awesome. So you can see that. Wow, that's actually a really good resolution for.
And we even know where we landed. This is the most amazing thing. The vehicle has told us where it's landed because we figured it out.
All right, let's see how closely it.
NASA works. NASA works. When we put our arms together and our hands together and our brains together, we can succeed. This is what NASA does. This is what we can do as a country. All of the problems we have, we need to work together to do these kinds of things and make success happen.
Awesome. So they know right where they landed. It's right where they expected to land, which is a really, really difficult feat.
Joining us now is the acting administrator of NASA.
So that was, I said it in my video, but to kind of give you an idea of what this is like, what these engineers just pulled off. It's hard enough to send a rocket up into space and have it land back on the Earth safely. That's really, really hard. But they went all the way to Mars. That's like getting a hole-in-one in golf, but with one hole in New York and the other hole in Los Angeles on the other side of the country. So imagine trying to shoot a golf ball from New York into a hole in Los Angeles, and the holes are both moving in different directions. That's basically what they just pulled off. They used all of their engineering capabilities to do this. Like I said, all these images start coming back. The information goes from the rover up to the satellite, back to this, what they call the Deep Sky Network, these 3 big satellite dishes, one in the western United States, one in Spain, one in Australia. They're specifically spaced around the world like that because that means that one of the dishes is always facing, no matter where you are in space, you'd always be facing at least one of those dishes to get information back. So we have that constant line of communication as the Earth rotates around. No matter where you are, you would always have a line of sight to one of those three gigantic things. That was built back in the 1960s for the original space program, the Apollo programs, things like that. That's part of what they call the infrastructure of space. These things that are built that, like, you can't go to Mars unless you have a way to communicate with people that are in Mars and things like that. So, that's just, there's all kinds of engineering that goes on. You saw those people sitting in that flight control going crazy. Those were just the people who were directly responsible for this landing procedure. There are hundreds, if not actually probably closer to the thousands of people who have worked on this project. people who write the software for the lander, people who design the lander, people who actually made it, the people in the metal shop actually cutting the metal for these things, electrical engineers that designed all of this, all of the people that do the calculations of how to get it on top of a rocket and send it to Mars. There's animators who did all of those animations that we were watching as it was coming in. That wasn't a live camera view of what the capsule looked like. That was a computer animation just so we could kind of follow along. It makes it a little bit interesting. So there's thousands of people that work on all of this and do all kinds of work. So really you could do any kind of job and work for NASA on one of these missions. It's, you know, they're not just the scientists. You know, the scientists kind of take over now and like, oh, okay, now what information can we get back from the rover and learn new things from? But all of these people that actually had to build this thing and fly it and transport it and make sure that it was safe and test it and do all of this. So there was lots involved in getting that there. So that was really awesome to watch. Thank you for tuning in and joining with us. Another momentous thing. Hopefully in a couple of weeks, I'll probably do another video. I'll give an update on the rover and what it's doing over the next couple of weeks. You can always go to nasa.gov and look for the so let me see if I can do it right here and I'll show you what to look for when we do that. If you go to nasa.gov and if you go to missions here, there's all of the ones here, but here's Mars Perseverance. You can go to the Perseverance rover. You can see all kinds of updates on it, what's going on with it. You can look for more stories. So you can constantly look and see what it's doing. You can see there's a blog about it. You can read up on the mission here in the overview. So there's all kinds of things that you can look through here and learn about the mission and kind of keep up to date with it as things comes out. I'll try to put that out, but yeah, thank you for joining me. Hopefully a couple people have put in the comments, you know, we wish we could be in the planetarium. I wish, trust me, nobody wishes more than I that we could all be in the planetarium. Just know we will be back there someday. I don't know when, but definitely I look forward to seeing all of our students and our community back there in the planetarium so we can do things. In the meantime, this is still a great way to kind of get together and check out all of this space stuff. Make sure you check out, I try to do my monthly videos, those evening sky excursions, to show you what you can see up there in the sky. Hopefully as the weather starts to get a little bit warmer, I'm going to get my telescopes out a little bit more. I have a new camera set up for them. If you tuned in back in December, back in December, I tried to get some telescope shots of the conjunction of Jupiter and Saturn. Clouds didn't cooperate too well with that, and it's been really cold. I've taken my telescopes out once or twice just for me, but in this cold, it's hard to spend a lot of time outside. So as the weather gets nicer, I'm hoping to do more of these live streams and maybe get some views through a telescope and things like that. In the meantime, just go outside and look up at the sky. It's amazing. You can always email me, Mr. Chantry, at the Planetarium website. You can get my email address. It's just achantry@methacton.org. Email me your questions, things like that. Love to help anybody out with things like that. But it looks like that's just about our time together. So thank you. If you want to jump over to that NASA, they'll keep going for a little bit here with the live stream from the NASA headquarters. But that was, the rover has touched down on the surface. Good to go. It's sending information back. It's right side up. It should be very good to go here. And start doing some great science over the next couple of weeks. So that's just youtube.com/NASA. If you want to keep watching that live stream that I have up there, you can go to that and do it. But thank you for joining us. And yeah, go outside, look up at the night sky, and as always, be excellent to each other. See you later, hopefully back in the planetarium at some point.